Welcome to How to Do Redox. A lot of people have problems with this. I'm here to help. So, let's say they give you an equation and it's MnO4 negative plus Fe2 plus yield sign onto Fe3 plus Mn2 plus. Now, a lot of people get confused when classifying them as reduction or oxidation. For right now, you just write out what kind of charge they have. If it's stated and it's by itself, then that's what it is. So if Mn says 2 plus, then it's just 2 plus. Fe 3 plus. 2 plus. And now with this one, when it's a combined atom, you set it equal to whatever the charge is. So if it's negative, then it would be -1. You set it equal to. And since oxygen's always -2, you put -2 times whatever it's being times as, guess you can say. So it would be 4. This would be -8 equals -1. Of course, Mn's on the side because that's what you're equaling it to. So you plus 8 on this side, you add 8 on this side, Mn will equal 7. So you go back up here and you plug that in. It would be 7 plus. So now is when you start classifying them as which one will be your reduction half and which one will be your oxidation half. So the whole gaining and losing electrons, just when you see reduction, just think about which number goes down. So Mn went from 7 to 2. It's the number's going down, so it would be a reduction. So your reduction half would be MnO4 minus 2 Mn2 plus. Obviously, your other side would be your oxidation, but that's because it goes from 2 to 3. It goes higher. So now with this, the reduction oxidation, just because the number went down doesn't mean it's losing electrons. Alright, so I'm going to explain the whole electron part. So let's just say your number is 2. 2 is just a number, it doesn't represent nothing, it's just a 2. Don't mind this 2, I messed up. So let's say you add 2 electrons. So since it's negative, it would equal 0. And since your number went from 2 to 0, it'd be classified as a reduction. So let me just give you an example so you can remember. Think of the whole electron as holes. Let's say you have a big hole while you're walking. And let's just say this hole could be repaired by adding electrons. So these 2 electrons, you add 2 electrons, let's just say it helps to cover 2 inches. And those 2 electrons, since you added it, it made this hole smaller. You see? Adding it makes it smaller. Same thing here. You add electrons, makes it smaller. So this is for a reduction. Now, let's do oxidation. So let's say your number is 2 again, but this time you take away 2 electrons. This will then equal 4. So again, you encounter another hole while you're walking, and this time you're taking out the electrons. And since you're taking out the electrons from the hole, pretend it's dirt, you're taking it out. So of course the hole is going to get bigger. So now the hole is this big since you took it out. So the hole would become bigger as you take out the electrons. This is oxidation. So again, when you add electrons, your number goes smaller because it's negative. When you take out electrons, your number gets bigger. Same thing here. Alright, now that we have our half reactions, let's start working with them. So, our first one was our reduction, and it was MnO4 negative to Mn2 plus. Right here, it's basically like basic balancing. So you have 4 O's over here, so you're going to need 4 H2O's. Why? Because your 4 goes to your O. The H's, you don't really have to worry about that because you can just add those in. Since 4 is the one that you wanted to get to, you use 4 H2O's to get to the O. And since 4 times 2 is 8, you're going to need 8 H plus. And H plus is, H has a positive because that's the way H is always written. It has always a positive charge. It has, so now since everything's balanced, you would write out how much electrons does each side have. This side has no charge on top, so it has no electrons. This one has 2, so you have 2 electrons here. On this side, you have a negative 1, and since there's a coefficient on this side, it would be 8 times the 1 up here, so it would be 8, equaling 7. So these two are not balanced. They need to come to an equal number. So you would have to add 5 electrons on this side. Okay, so 7 minus 5 would get you the 2. So now that they're even, you would rewrite this, of course, because this looks all messy. So it'd be 5 electrons on this side. All I did here was just rewrite it. I didn't add nothing, I just rewrote it. So this is one of the half reactions. Now we need to work with our oxidation half. So now that we're done with our reduction half, now we work with our oxidation half. This one is a little easier because there's no other atoms involved, it's just iron itself. So Fe2 plus, Fe3 plus. Since it's already balanced, since Fe's on this side and Fe's on this side, there's no extra coefficients. See how many electrons there is on each side. 3, 2, and of course remember to show what kind of charge they have. So you need to balance them out. So if you add 1 electron on this side, you make the number go down. So it's be 2. So now it's balanced, you just rewrite it, and it would be Fe2 plus, Fe3 plus, with 1 electron. So now that we've balanced each set of half reactions, you would now combine them, but not yet, just have them side by side. Be a lot easier to do it. was your reduction, your oxidation was so the next step is to make the electrons equal. Since this 5 on this side, 5 on the reduction half, and there's only 1 on the oxidation. So you would need to times this whole equation by 5, getting you 5. Oops, sorry. So now you have each one balanced. Now this is when you would cancel out. So if you have 5 electrons on this side and 5 electrons on that side, you do not need these anymore. And since there's no H2Os on the Fe side, then there is nothing else you need to cancel out, because there's nothing else on the opposite side that would make it cancel out. So for right now, you would just write out what you have left, which in this case we only took out the electrons. Oops. Gotta add in the Fe also now. And again, just to make sure that you're balanced it correctly, you would take the overall charge to see if they match. So 5 times 2 is 10. This is just negative, so it's just a negative 1. 8 times 1 is 8. So overall, 8 minus 1, 7. 7 plus 10, you'd get 17. This side, you have 2. And you have no charge on the H2O, so you don't have nothing there. 5 times 3, 15. Add those together, you get 17. So your redox should look like this. I want to thank you guys for watching this video. It's chemistry with Crissy. See you next time.